We should start now. Welcome to the doubt clearing session number 4 for Metal Mediated Synthesis-I. My name is Shiva Singh. I am your Prime Minister's Research Fellow Teaching Assistant for this course. This course is coordinated by Professor Devabrata Maiti at Department of Chemistry, IIT Bombay, and my PhD is supervised by Professor Pradeep Kumar Maji at Department of Polymer Process Engineering and Professor Kaushik Ghosh at Department of Chemistry, IIT Roorkee. Before starting this session, I should tell you what this session will consist. Initially, I will introduce myself to you, and then I will be providing you the sessions for doubt clearing. The first session will be like first half will be consisting assignment number 4 of previous year, and the second session will be consisting assignment number 2 of year 2022. As the deadline for this assignment is already crossed, so we can solve this assignment also. Submission date of this assignment is already crossed, so we can solve this assignment also. And I will be discussing basics involving in it and the explanation of the questions and reasoning for them. So my name is Shiva Singh, and I have been in touch with the research of organic synthesis as well as material sciences. My research journey started from Department of Chemistry, Delhi University, with Professor Akhilesh Kumar Verma, and there I worked with the field of transition metal catalysis, which consists of Sonogashira, Stille, Heck, Suzuki type of couplings. Then uh, I have joined Professor Alakesh Bisai at IISER Bhopal for my summer internship. There I did total synthesis of indoles and terpene indole based alkaloids. Further, I did my master's project with Professor Chayan Das at Visvesvaraya National Institute of Technology and studied the natural rubber composites which were reinforced with chemically modified cellulose nanocrystals. And during this journey, I have accomplished few of fellowships and award, in which the first one is Inspire, and I was the Inspire Fellow from 2014 to 2019. Then I also got selected for SN Boost Scholars Program in 2018. I have also qualified GATE, and I am also an Inspire JRF. And recently, I got selected for Prime Minister's Research Fellowship from December 2020. So if we start from week 4 of 2021, the assignment number 4, the question is what will be the major product? Firstly, we have to see the catalyst here and the reactants. Okay, so while seeing this Grignard and Titania as a catalyst, we have already discussed in assignment number 0 of this year that it is your Klinkovich reaction. Okay, so, firstly, I will give you for 1 minute to guess the answer, and I will say, do not guess the answer, go with the basics and tell me the answer. You have 1 minute to predict the answer, then I will be proceeding and telling you what may be the answer. Yeah, you can communicate with me in the chat box. Okay, Kritika is saying it is B. Fine. See, what happens in such type of questions? First, you have to see and observe the question. What they are saying: minor product, major product, react reaction is given already, and I have already told you the name of the reaction. This reaction is done on the ketones or aldehydes for uh, on this center for the formation of cyclopropanes. Okay, so the answer cannot be this or this because we already know uh, that a cyclopropane will be forming here. And if we see here in the Grignard, we have 8th mate probe. Okay, whenever the chain extends, the selectivity comes, and here the explanation. And further, I would suggest you to go through this link provided here and get the better understanding why this mixture is obtained. If we see here 2.5, that means it is major, and 1 means when we get one part of this product, 2.5 molecules of this product are already formed, and this happens due to the magnesium halide, that is our uh, rmgx. Okay, grignard. Whenever the r chain length is increasing, the selectivity increases, and this is how the product will be forming. The next question is again the similar reaction with some modifications. Here, see, if we see here, we had this ester here. Okay, but this ester is now replaced with this uh, amine group. Okay, but the product will be similar. Okay, so you have to just tell me the answer. Means I have already told you the answer. We have the four options here. The name reaction is same. We have this catalyst. The identification is catalyst with Grignard. 1 minute you have. Guess the answer. Yeah, because we can see here that only one cyclopropane is forming, and this particularly this reaction is for cyclopropane formation only. So the name of the reaction changed slightly. Okay, it is called Demerze variation in the Klonikowicz reaction. Okay, let's move to the next question. Again, the similar type of uh, reaction, and just tell me the answer so that we can proceed to the next question. We have Grignard here, we have titania catalyst here, and we have a ester here. Okay, Sri Ram is saying the answer is B. uh, okay, anyone else? Fine, the answer is B only because I have already told that this reaction is particularly for the formation of cyclopropanes. So in this method, in manner it will go, the mechanism will be in this manner. Fine. And for better understanding, you can go through this research article published in the ACS publications, the similar type of optimizations and reaction they have did. Okay, I think till here it is clear. I think I should move to the next question. Yeah, fine. See, it is the revision. This question I have already addressed to you guys in the assignment number 0, and that was the dry run, and it is already uploaded on YouTube. So I would be expecting the answer from you. Find out the correct mechanistic pathway for Pauson-Kahn reaction. That is also PKR. You have 1 minute for the question. I have already addressed this question, I think, two times in the previous runs. Fine, let's see the mechanism of this PKR reaction. What happens? See, the reaction starts from here. Okay, the alkyne insertion happens with the catalyst, right? Whenever the alkyne inserts, the CO group leaves. Okay, then again alkene coordination. After alkene coordination, here, alkene coordination, what happens? Then alkene insertion in the system. Okay, then what happens? CO insertion. See here. Then loss of this catalyst. Okay, and product formation. Loss of the catalyst here. Okay, and product formation, and again CO insertion, regeneration of catalyst, and cycle keep on running. So what may be the answer? Can you please tell me now? Firstly, alkyne insertion, CO removal. Okay, see, ठीक है, then again CO removal here. Okay, then alkene coordination here. Okay, then alkene insertion here. See this part, alkene insertion occurred here. Okay, then one CO here, and CO insertion, loss of the catalyst. See, is so if you see the catalytic cycle of a reaction, you can directly tell what may be the pathway of the reaction and what are the steps involved in it. Fine, let's move to the next question. Which type of Grignard reagent is undergoes Kolesnikov reaction? Okay, so now we will be discussing a bit of mechanism of this reaction that will be telling you like which type of Grignard is used here. But still, I will give you a chance to guess the answer. Which answer can be the best suitable answer for this problem? You have 1 minute. Okay, it's from Hindu. It's she's saying Grignard reagent containing aromatic rings. Okay, anyone else? See, it is getting interesting. Like if you guys are interacting with me, it will motivate me and like it will give me a lead how to make you understand like what the demand of the problem. See, such type of questions will always be there, whether it is GATE, whether the certification course of this course only or NET. You will be facing such type of questions only. Nothing new will be coming there, and I am telling you that this portion is very important. It comes like with the weightage in either net or gate. Okay, so you should focus on them also. Fine. Okay, let's discuss. See what is happening here. This is our catalyst. These are the two molecules of our Grignard reagent. Fine, and it gives et to et here, right? Means this is our titania, one et and second et, right? So at the end it will be having hydrogens, right? This hydrogen, this carbon bond and this hydrogen, this bond breaks and it takes the electrons here, titania, right? It leaves. Okay, and this hydrogen goes with it and this ethylene leaves. Fine, suppose we don't have a hydrogen here, right? Alpha and beta position, right? We have here CH3 methane and methane, right? There is no hydrogen here and you know C bonds are very strong, cannot be broken, right? So if this cannot be broken, this will not be going here and it will not be leaving, and if it is not leaving, the reaction will not proceed. So what is the requirement of this reaction? Grignard reagent containing beta hydrogens at this place. Fine, understandable. Shall I move to the next problem? Fine. See, this is a typical question. Fine, and for the uh, mechanistical studies, people have done a lot of work on this PKR reaction. Fine. So this question becomes important in the aspect of researchers. So the question is, in the catalytic cycle of asymmetric Sudokan reaction using SS EBTHI titania complex C. This is your metal. These are the ligands. Fine. Which step determines the stereochemistry of the product? PKR reaction we have discussed already. Okay, but asymmetric PKR is having for many years people have discussed and made their statements for the mechanism of this reaction so that they can tell that which stereoselectivity or diastereomers how they are forming and how it is getting which stereomer will be forming more and all. Fine, a lot of discussion was there for this particular reaction, and at the end in this research article in 1999 they have established that uh, during the cyclization, see this 6b, right? Cyclization step, here only cyclization occurs. ठीक? In which manner the cyclization is happening is governs the stereochemistry of the product. Okay, so that means which step is governing the stereochemistry is cyclization. Fine. And for further more studies, if you want to go through deeper knowledge, you can try this research article. Okay, this is like a easy question and interesting one. Phosphine ligands are both sigma donors and pi donors. State whether this statement is true or false. We have studied them in graduation also, and in so many like basic chemistry we have studied these ligands, and we know the tendency of these ligands. Either they are pi donor or sigma donor, whatever they are. You have to just tell me the answer. Is the statement is true or false? Then I will be discussing whether it is true and false. Whatever it is, I will be telling you the proper answer. But before that, I want you to give an attempt on this question. Anyone have any answers for this question? Phosphine ligands are both sigma donor and pi donors. Tell me whether this statement is true or false. Okay. Okay. Sriram is giving the answer and saying that it is false. Okay. Fine. Okay. The answer is right, and I should tell you how. If you go through the molecular orbital diagram of this phosphine ligands with the metal, okay, what happens initially? The sigma bond will be forming, and at that position the lone pairs on phosphorus will be sent to the metal. That means sigma donor it is. Okay, but what happens when the pi bond is formed? This pair is sent back to the phosphine. Okay, and what will be happening? A back bond is forming, that is represented like this: metal to ligand, right? So back donation is happening, but what they have told that they are pi donor, but what is happening here? They are accepting it. Okay, so they are not pi donors. That means the statement is false. Let's move to the next question. This question I have discussed, I think, two times. How many equivalents of Grignard reagent is generally used in Kronikovich reaction? And I want an answer for this question, and I will not be discussing this because it is second or third time I'm encountering this question. Anyone telling me the answer? Fine. Geeta is saying the answer is two equivalents. Fine, fine. And she's right because I have already discussed it here. Where? Here. See? You have to just observe. Yeah, Hindu also. Yeah, you are right. It is two equivalent. See here. Two equivalents are involving the cycle, and two are here. But once the cycle is started, it will be needing only two equivalents of Grignard reagent. Fine. Okay, let's move to the next question. Means the assignment number 4 of year 2021 is over, and it will be giving you idea how to solve the assignment number 4 of this session. Fine. So in this session, assignment number 1 I have discussed in the previous session, and I will be discussing assignment number 2 of this year because the submission date is already gone, so I am allowed to discuss it with you. Okay, and it is kind of revision for you. So let's start it. Name the following coupling reaction. So whenever they ask about coupling reaction, what you have to check? Catalyst. What we have here? What is this? I want to know what is this. Answer me in the chat box. This is the solvent. Okay. No, no. You are telling me the answer. I'm not asking the answer. I'm asking what this. Yeah. Shmita is saying it is base. See, we have. I'm just telling you the approach. How you have to approach to the question, right? ultimately you have to answer them now. The research part is later one. So how to approach or hold a question? Palladium is here, it is a catalyst. These are the ligands: base, solvent, boron complex, and this is the alkene complex. So we can say here we can have a coupling, and bases are used in Suzuki. Boron complexes are used in Suzuki. So which reaction? Directly you can answer it: Suzuki reaction. What I am trying to tell you here, that I am making a essence that how your mind should work when you are seeing such type of questions. Okay, I think it is the understandable problem. So now we have to move to the next question. In still a coupling reaction, the order of transmutation for aryl is more than alkyl. State whether the statement is true or false. You have 1 minute. Answer the question. Then I will ask few more questions about the still a coupling. Do we have an answer? Okay. False. Sri Ram. Okay, now we have a contradictory answer. True. Hindu is saying true. Sri Ram is saying false. Okay, we have two options only. We don't have none of that. Okay, let's move. It's true statement. Fine. Let me tell you how. Methyl and butyl groups are often used as the other three R groups. But what happens now? These are very like have very prone to get reaction and form a product. Okay, that is why alkyls are not encouraged to use as a ligand. Fine, यही तो question. Yeah, it is the question only. Either aryl or alkyl. Alkyls are very prone to react. Okay, so they will form a non-transferable ligand product, and this product is not desired. That is why alkyls are not used. Fine, that's why it is a true statement. Transmetal, there is still possibility that alkyl coupling side product would be forming, and which is not desired. Okay, such type of products are called non-transferable ligand products. Though there are cases that show benzyl steners are able to couple through steric catalysis at higher temperatures, both electron donating and electron withdrawing properties of the R group is favorable for transmetallation. Transmetallation, whenever we have benzene type of stannous complexes, they are easily prone to transmetallation. But whenever they are alkyl, they are very less prone to transmetallation. Even they form non-transferable ligand products. That means they are not moving from metal to another metal. Okay, so they will hinder or retard the rate of the reaction. Okay, I think it is understandable. So correct answer is true. That means A1 is the true answer. Okay, the right answer. Fine. Let's move to the next question. The reactivity pattern of aryl halides in the coupling reactions is usually followed. This question I have already discussed. I want to answer ASA. Very easy question. Okay, Asmita is saying D. Fine. Anyone else? Geeta is also D. Anyone else thinking about any other option? Okay, now I have the query why chlorine is on the least priority, least reactive. Why? So you should go through the. Okay, Hindu is saying answer C. Fine. Okay, anyone else? Fine. Let's approach the question. If we see chlorine, okay, chlorine, aryl halides, aryls, what are they? Somewhere they will be having end group as a carbon with halide. Fine. This can be chlorine, bromine, iodine. Fine. But They are of same group. Okay, better overlapping of the bonding orbitals. Better overlapping, that means stronger the bond, more bond order, very difficult to break the bond. Okay, that is why chlorine will be on the lowest. Too inert. Why too inert? I told you the overlap is too good, so that size difference is very less because they are of same group. So overlap is too good. That means bond order is very high. That means they will be very least reactive. Okay, fluoride is the least effective leaving group. Okay, in the halides, because fluoride anion is most basic. Like what she will do, like fluoride will do what, it will contract its electron towards its orbital. That means they will be not sharing at all. Okay, the rule applies to both SN1 SN2 type of reaction, because in both cases RDS involves the leaving group. Okay, whenever the leaving group is leaving, that after the reaction will be proceeding. Okay, so the trend is iodine, bromine, chlorine, then fluorine. Okay, let's move to the next question. I will not tell you the answer. I have told you the approach. First, you have to do what? Catalyst, partner metal, RX. Okay, just you have to check which partner metal. This partner metal is used in which reaction. You have to tell me this only. You don't have to see the whole reaction. Just see the partner metal, that is zinc, and zinc is used in which coupling reaction. The answer you know. Tell me the answer. Anyone? Come on. Okay. Anyone else? Fine. Only two, three people are interacting, but I'm liking it because it's, yeah, good, good. It's an interactive class. Like I'm enjoying the interaction with you guys. Fine. It is a Negishi coupling reaction because the zinc in the coupling reactions, zinc is the partner metal in the Negishi reaction. That's how copper is the partner reaction in Sonogashira, and boron complexes are partner in the Suzuki. स्टीले में tin हो जाएगा. Fine. So that is the way how to identify the reactions. Fine. Let's move to the next question. Come on, tell me the product, and also tell me the name of this name reaction. Not a big deal. Everything is here only. Do I need to explain it? Okay, just tell me the name of this name reaction. Okay, tell me the name of this coupling reaction. Anyone? It is a coupling reaction. Fine, fine. I want the name of this coupling reaction first. Do we have a name for this coupling reaction? I just have answered. Okay, fine. It is a Sonogashira coupling reaction, and it is used for the coupling of carbon of alkyne with another carbon, like aryl halide. So it's Sonogashira coupling, and this base is used for generating the carbon complexes. Okay, so these carbon complexes. Okay, so if we see here, this part can be written as R. Fine, Rx. Okay, aryl halide. Fine, this is our alkyne. Fine, terminal alkyne. Okay, this is our catalyst. This is our partner metal. We have the base. This is the solvent, right? And see here, R coupled with the alkyne. Fine, this is the product. That means the product is A. I think it is understandable. Not a big rocket science. You need to just approach the question. Just ask the question which coupling reaction you are, and you are getting the answer. Fine. I think move. Let's move to the next question. This is the answer. Again, see, they have told you the name of the coupling reaction. Fine. To prepare the following compound via Suzuki coupling, one of the coupling reagent. Just you have to use the aptitude in this question, nothing else, just the aptitude. You have, okay, take a 2 minutes. You have 2 minutes for this question. Okay, Asmita answered B. Fine. Anyone else? Indu D. Okay, fine. Anyone else? Okay, fine. Let me tell you one thing. See all the options. They all have nitrogen in it. Okay, Gita is saying B. Fine. They all have nitrogen in it. That means the boron complex is formed with this moiety, right? And this is your aryl halide. Fine. That means, okay. Let me just hold the screen here. Then I can write. Yeah, fine. That means, pardon me for the writing, but I think I will make you understand. See, the manner I am doing this, that is also called the retrosynthesis. Fine. Whenever you blow, like, keep on like breaking the molecules and make the synthons and all, that is kind of retrosynthesis. That will be very useful for you if you are pursuing your research in organic synthesis. Okay, fine, that is the other part. Let's focus our question. Fine. This should be our boron complex. For boron complex, what we are doing? B. Okay, OH2. We have the answer here. Now tell me which one, like, just you have to move and fit. The distance of nitrogen from boron should be one carbon after. From here, if just see this, one, two, and third position nitrogen, right? If we say here one, two, third, no, crossed, okay. We see here one, two, crossed, one, two, crossed. See, one, two, three. Directly the answer. Do not do the basics and all, just see the aptitude here. Just you need the aptitude in such type of questions. You know what is Suzuki reaction. You have to just break the molecule, decide which one your aryl halide or alkyl halide, which one is your boron complex, and then you will be directly giving the answer. It will not take more than 1 minute with such type of questions. I hope you have understood this question. Shall I move to the next question? Shall I? I think let's move to the next question. This is the, like, mechanism of this reaction, and see, this is the your answer, and the correct answer is B. Fine, and I have already given the detailed mechanism in the previous sessions, so let's not discuss with the mechanism and all. Okay, this is a different type of problem, and this is very interesting reaction also. Aryl halide, carbon monoxide, octyl butane, and palladium catalysis. Do not get confused and make it a Suzuki coupling reaction. It is just some alterations in it. So I want a prediction from you guys. What may be the answer? You have 2 minutes, around 1 minute. Okay. Okay, Gitika is saying it's C. Fine. Okay, Sriram also C. Anyone else? Hindu also C. Good. See what is happening here. We have a aryl halide. Fine. Let me tell you how to eliminate the options. In with such type of questions, you need to be cunning. Fine. See, this is your metal. Metal will be inserted in this portion, right? But it is not affecting this bond, and nothing else is here which is affecting this bond. Fine. That means these two options are already cut from the picture, right? Now you have only two options, and already people have guessed that it is the third one. So let's see how the third one is the answer. We see here firstly the insertion, then carbon monoxide as a double bond. It will be treated here, which is called CO insertion. CO will be if you go through organic metallics, the CO will be inserted in between this uh, aryl group and palladium. Fine, CO is inserted here. Then transmetallation will be occurring, octyl group will be coming here. Okay, then again reductive elimination, our palladium catalyst will be out, and the product is this. Fine, slight alteration, a slight alteration in the reaction, but product now we know. Fine, so the correct answer is C. Good try. So it is understandable, right? You can understand this. So this is how this is boron complex is formed. Fine. Okay. 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 Let's go to the next question. State whether the statement is true or false. Reaction of alkene with the diazomethane produced long chain alkene. See, diazomethane whenever reacts with alkene, what it gives? Is it a long chain alkene? You have 1 minute for the answer, and I have already taught you this reaction in the previous sessions. See, yeah, yeah. Firstly, I want the answer. I will not explain it. Okay, false, true, false. Okay, okay. Anyone else? Fine. Let me tell you what happens. Suppose your methane here. Okay, nitrogen here. Okay. So you know the generation of whenever you will be giving delta or h nu, we will be getting a what? Carbene. And whenever a carbene reacts with alkene, what it gives? Isn't it? So from where you will be getting a long chain alkane? It's a false statement. You will be getting cyclopropane. See, fine. Let's move to the next question. State whether the statement is true or false. Bulky ligands can retard the beta hydride elimination. See, as we have discussed in the previous session, some of the reaction require beta hydride elimination, and some do follow a different pathway. Okay, for that different pathway, what do you need? They are saying bulky ligand. Is it a true statement or a false statement? Okay, true. Anyone else? True, true, true. Great. Too many answers. Fine, let's check it is true or false. It is true, and if you read this statement, I have compiled this statement for the better understanding, and I have already told you that some places we do not need the beta hydride elimination, right? In some of the places we need another thing. Okay, that is not beta hydride elimination. So for that, for retarding that step, we use bulky ligands. Okay, the last question for you guys. RDS in the Stille coupling reaction. Rate determining step in the Stille coupling reaction, whether it is oxidative elimination or transmetallation, beta hydride elimination, reductive elimination. Tell me. Okay, okay. Too many answers. Okay, okay. A, D, B. Now only C remaining. Someone please answer C. Okay, B. Fine, fine, fine. Okay, let's see the. Okay. Okay. Someone answered C also. Okay, now we have all the options. In the group, you guys cannot like answer the question, right? Now I have all the options as selected: A, B, C, D. We don't have E here. They're asking rate determining step in Stille coupling reaction, and it is a revision of your assignment which you have submitted. I think previous week. Okay, fine. No one is answering any other option here. Fine. Okay, with the like, if we see the polling, B is winning. That means transmetallation. Fine, transmetallation is the right answer. Let's see how. CO can coordinate to palladium catalyst after initial oxidative addition, followed by CO insertion into the palladium iron bond, resulting in subsequent reductive elimination to ketone. Okay, the transmetal step is normally the rate determining step. What is the rate determining step? Just tell me, like, one word for RDS. What is RDS? What is RDS? What is RDS? Slow process. Okay. Anyone else? Kinetically, whenever like we are calculating the rate of a reaction, all the steps happen simultaneously and in very fast manner. But when we observe a slow step in a reaction, okay, that can be used for the calculations to determine what is the rate of the reaction. Okay, that means a slowest step of a reaction can be termed as rate determining step, and in this reaction the transmetallation is the slowest step, this one. Okay, the slowest step of this reaction, and that is why it is the RDS step. Okay, I should thank you guys for the patientful uh, participation in this doubt clearing session, and it was the final session from my side. After onwards, I will be addressing the issues related to my presentations on discussion forum. Okay, and it was great, and I am very thankful, and I should acknowledge my friends and colleagues and lab mates for providing me uh, courage to participate in this program. It was very nice with you guys. And do if you do have any query regarding this session right now, and we can have the query because we have 4 minutes remaining. And after that, I will be available on the discussion forum also. So either you can give me the queries here, and I will be uploading them on the discussion forum, or we can discuss it here only. Anyone? And I'll be available. Like, you can search me out and find me and get your queries with me. Okay, fine. I think it's done here right now. And I should stop sharing this presentation. This card, right? And this presentation will be available on the uh, YouTube, as well as you will be getting a link for this presentation. All the very best for your certification course. Thank you very much for hearing me out. Goodbye. Welcome, welcome. Thank you.